Hello everyone, welcome to Bytes channel. This is Vijay. Today we are going to see some of the best practices while deploying production application in Kubernetes, addressing key areas such as high availability, security, resiliency, and other best practices. I have identified some of the important Kubernetes features that helps the production application deployment to be highly available, secure, and efficient. Without further delay, let's get to it. Let's watch a quick demo of what we've seen so far. I'm going to deploy this spec into my test Kubernetes cluster and show you guys what we went through today. Let's get to it. I have the deployment file checked out in my local machine, which I'm going to deploy. I've deployed it. Um, let's see if the pods are up. The pods are up and running. So let's go over and see some of the items that we covered so far in this session. So the first things are externalizing your application configurations and secrets through by using the configmap and secrets. Let's see what we've created here. So I'm going to do a get of the secrets. Here I have my um, certificate. I have my .env file and I have my database username and password stored as a secret, which is base64 encoded. And I'm gonna do a get of the config map to show you guys other application configuration which I've externalized. So there's this root CA, which is the certificate file that we wanted to load it into the container. And we have other application configurations, which are some key value pairs as well as some file like properties file or any sort of file that you wanted to load into the container, which are non-sensitive application configuration that you wanted to load. You would put them under this config map. So I have two config maps, one containing the one containing the certificates, another containing the key value pair of application configuration and properties file. Then I have the secret containing the DB username password and the .env file, which is some bunch of environment files stored in a .env file. Um, let's go over and check out the number of parts. So as you can see here, I have three instances of my application running here, which is basically the replicas that we specified, which is the desired state, making sure your application is highly available. So I have three instances of my app running, and let's also see how the pod anti-affinity has worked. So, like I said earlier, pod anti-affinity makes sure no two pods are running on the same worker nodes. So it helps you spread your pods uh, across multiple different worker nodes. So in this case, all the three pods should be scheduled on different worker nodes. Let's go and describe the pod to see what really happened there. Okay. So you see here, this is on worker node 1. I'm gonna do a describe on the next pod as well. This is worker node 3, and let me do a describe on the other pod. And it's worker node 2. So as you can see, we had three pods and all three pods are scheduled in three different worker nodes, making sure your application is highly available. So even if one worker node, let's say this worker node 2 goes down, you still have your other two pods running on worker node 1 and worker node 3, which are up and running and able to take traffic. So that's something the pod anti-affinity lets you do that. Now, these are some of the volumes that are required to load or mount your application files, or the .env file that you want to load it into your application container. You would be able to do that by specifying the volumes and set of volume mounts. So we can go inside the container and check it out if we are able to see the certificate file as well as these properties file were mounted into the file system of the application container or not. We can also check the .env file getting inside the container. Let's go and do that. So I'm gonna list the pods again, and I'm gonna go inside one of the pod. To show you guys if we are able to load those files into the container. Okay, so now let me go to the path. So let's go check out the path here. So the path, it's going to be our /config, which is going to hold our .properties file. So I'm going to go into cd to the /config here. So here you can see the two files, user.properties file and app.properties file, mounted into this file system /config. So /config is nothing but your um, app config, which is again coming from this config map. So if I go here, the app config map is nothing but containing your two files, app.properties file and user.properties file. So those are mounted into the file system /config, which is where I wanted it. So I can see those two files. I can cat this file as well. So a lot of times you in a typical production workload, you would want some files that are required for your application to be inside your container file system. You could do that through these config maps by specifying the volume and the volume mount. So here I can see my content of the app.properties file, hello world and foobar key value pairs inside this app.properties file under /config file system. Similarly, I can cat the user.properties file, and I can see the user information here. So user 1 ABC, user 2 XYZ. Yeah. So next, the certificate file, I loaded the certificate file under etc. Let me check here. Under etc secrets, etc SSL certs. Okay, let's go to that path. etc SSL certs. I'm going to list here, and I can see casert.crt file. So the file name, let's go back the top. So look at the file name here, casert.crt, which is what I've specified the file name to be, and the path is the etc SSL certs. So I'm in that path, and I have the cert. Let me cat this file now. So you can see here the certificate information is loaded into the file system here, and you can use this certificate for um, making sure your application connects successfully with SSL and such. So that's another thing. The next thing is the .env file coming from the secret. So this is base 64 encoded. Now when you load it into a file system, it would be automatically decoded, and it would be available as a file. So I've loaded the .env file into the path /user app secrets. Let me copy this path system and let me go to that path system. Since it's a dot file, so you need to do -al to list all the dot files, and I can do cat. I have the file content here. So this particular .env file, which is base 64 encoded, contains these values, which is what I could decode and see the information here. So clearly we can see we have all the information that are loaded. Now what about these key value pairs which were set as environment variables, right? So we have set a lot of environment variables by referencing those config maps and secrets. You could also print that. So you could print those, print env, and you should be able to see those environment variable. For example, let's see here, app username, app password, app external endpoint. Then you have time zone. All these are environment variable. You have DB username, cluster name, um, app version. These are all some of the environment variable that we have set, which is all available and set as well. Yeah, so those are there. Now, let's get back again to another important thing that I wanted to show you guys is the security context. So let's look at the security context. So I've said run the process as non-root, right? So let's see here. So I'm gonna clear this off. So I'm gonna, okay. Here you see the UID is 1000, right? So um, you can see the user is running as non-root here. So it's very, it makes this particular container run securely, that you're not giving any sort of root permissions that could be exploited, because providing root permission could have access to the host system where this container would be running, which makes it vulnerable. So over here, I've changed the user to run as non-root. Here, the user ID is 1000, which is what we are seeing here. Yeah. Okay. Yep. Okay. And moving on, let's look at this request and the limit set as well, and uh, the liveness probe and the readiness probe next. Okay. So let's get out of this container now, and now I'm gonna list the parts again. I'm gonna show you guys the liveness readiness probe and yeah, the request and the limits. Let's describe the pod. Okay. A lot of useful information are available here. So here you can see it's running the liveness probe, it's running the readiness probe, and what else? The request and the limit over here. So you can see the request and the limit here. I'm gonna put this side by side here. So you see the request is CPU is 100 M and then memory is 100 megabytes. Similarly, the upper limits which have been set. So this makes it to use your resources efficiently by specifying both your request and the limits, and that has been configured. Okay, one final thing that I wanted to show you guys is uh, the pod disruption budget. So PDB, and I'm gonna list the PDB. Okay, you see here, so the allowed disruption is 1, so which means at any given time when there is some scheduled maintenance going on, if a worker node is taken down, PDB would allow only one pod to go down at any given time. So it wouldn't allow, let's say it wouldn't allow the second worker node to go down in this case, because you've already taken down one worker node and one pod is already down, and Kubernetes wouldn't allow the next worker node to proceed with the maintenance, taking by stopping the second worker node from going down. It would block the upgrade and wouldn't take down the pod. So that's what PDB lets you address. So as we can see, this is one of the best practices that we recommend as well. So the PDB is set. So yeah, pretty much I think I've covered most of the topics here. So addressing those three key areas, high availability, security, and resiliency. Uh, yeah, thank you. Thanks for watching. And do subscribe to our channel. Bright by Bytes, share, comment. If you want to contribute to this project, feel free to contribute, comment. If you feel anything is amiss, we will address those. Thank you.